Hello viewers, in today's class we are going to discuss one important definite integral involving absolute value function, right? So here we are given the problem. We have to integrate absolute value of x square minus 2 from minus 5 to 5, right? So let us start and let us call this integral as I, right? So I is the integral, and now here let us take this integrand as f of x is equal to mod of x square minus 2, right? So now here we see that this function f of x is an even function, right? So it is an even function. So why it is an even function? Let us see. Let us replace x by minus x, right? So in f of x we'll replace x by minus x. So we have f of minus x is equal to mod of minus x square minus 2, and we see that here minus x square is simply x square, right? So we get the original function, that is f of x, right? So viewers, we see that f of x is an even function because f of minus x is equal to f of x, right? So we have already dealt with even and odd function in our earlier videos, right? Okay, so once we have established that f of x is an even function, we'll now apply a very important property of definite integrals, which states that if we have to integrate from minus a to a f of x dx, then if f of x is an even function, then this integral is equal to twice of the integral from 0 to a f of x dx, provided f of x is an even function, right? So we know this property. So if we compare these two integrals, we see that the value of a is 5 and f of x is mod of x square minus 2, right? And which we have already shown that it is an even function, right? So therefore this integral I, which is minus 5 to 5 mod of x square minus 2 dx, is now equal to 2 times the integral from 0 to 5 f of x, which is our function mod of x square minus 2 dx, right? Okay, so now our aim is to evaluate this integral. Now we'll make use of the definition of absolute value function, and let us see the definition. The mod of y is equal to positive y whenever y is greater than or equal to 0, and minus y whenever y is less than 0, right? So here we have taken the variable y for explaining the definition of absolute value function, right? So mod of y is equal to plus y whenever y is a positive number, a real number including 0, and mod of y is equal to minus y whenever y is less than 0. It implies that y is a negative real number, right? Okay, so now let us apply this definition to this function, right? That is mod of x square minus 2. So let us replace this y by x square minus 2. So now we have mod of x square minus 2 is equal to plus, that is positive x square minus 2 whenever y is greater than or equal to 0. So it implies that x square minus 2 should be greater than or equal to 0, right? and mod of x square minus 2 is equal to negative of x square minus 2 whenever x square minus 2 is less than 0, right? So we can also write it as minus x square plus 2, right? So whenever x square minus 2 is less than 0, right? Now let us take this inequality. So here we have x square is greater than or equal to 2, right? And if we take this inequality, then we have x square is less than 2, right? Okay, now we can here use a very important inequality which says that if we have x square is less than say a square, then x lies between minus a and a, right? So this is an important inequality which will be used to solve this one, right? So here we have x square less than a square, so x lies between minus a and a. So here we have for a we have square root of 2. It means we can write it as x square is less than root 2 square, right? So now applying this inequality to this one, we have minus root 2 is less than x, and this is less than root 2, right? Okay, so we have done all these things, and now let us come to our original integral. Now here we see that x varies from 0 to 5, right? So here we have the number line, so here we have 0 and 5 lies somewhere here, and here we see that this number, that is root 2, right? So this root 2, it lies somewhere here, right? So if we take we can write it like this. See, here we have 1, then we have 2, then we have 3, then we have 4, then we have 5, right? So root 2, it lies somewhere here, that is 1.414, so it lies somewhere here. Okay, so now we have to split this integral, right? This integral as a sum of two integrals. One is from 0 to root 2 and other is from root 2 to 5, right? So I is now equal to 2 times, here we have 2, and this integral can be split into two integrals I1 and I2. Now I1 is from 0 to root 2, and here we have mod x square minus 2 dx, and here we have root 2 to 5, and here we have mod x square minus 2 dx, right? Okay, so now viewers, let us rewrite these two integrals as, see, here x varies from 0 to root 2, right? 0 to root 2, and when x is less than root 2, right? When x is less than root 2, we have mod of x square minus 2 is equal to minus, here we have the integral sign 0 to root 2, and we have minus x square plus 2, right? Because see, here we have taken the sign of mod x square minus 2 as negative because x lies from 0 to root 2. It means all the values of x which lies between 0 and root 2, this expression, that is x square minus 2, is a negative expression, right? So x is less than root 2, so here we have mod of x square minus 2 is equal to negative x square plus 2, and here when x lies from root 2 to 5, then Obviously this expression is positive because here we have x square is greater than or equal to 2, right? So here we have plus x square minus 2 dx, right? Okay. So now we can separately solve these two integrals, and this is I1 and this is I2, right? So I1 is now integral from 0 to root 2, we have minus x square plus 2 dx, right? Now the integral of x square is x cube over 3, and here we have 2x, right? The integral of 2 dx is 2x, and the limits are from 0 to root 2. Now substituting the limits, so we have root 2 cube over 3 plus 2 root 2, and then we have minus, here 0 cube is 0, and here 2 times 0 is 0, right? So now we have here minus 2 root 2 over 3 plus 2 root 2, that is minus 2 root 2 plus 3 to the 6 root 2 over 3, that is 4 root 2 over 3, right? So the value of this integral is 4 root 2 over 3, right? Now let us solve the integral I2. Now I2 is given by root 2 to 5x square minus 2, and the integral of x square is x cube over 3. Here we have 2x, and the limits are from root 2 to 5. Now substituting the limits, we have 5 cube over 3 minus 2 5s are 10 here, and then we have root 2 cube over 3 minus 2 root 2, right? Now this is 5 cube, that is 125 over 3 minus 10, and here we have 2 root 2 over 3 minus 2 root 2, right? Now this is 125 minus 30 over 3, and here we have 2 root 2 over 3 minus 6 root 2, right? And now 125 minus 30 is 95, and here we have 3, then we have minus 4 root 2 over 3, and this is 95 over 3 plus 4 root 2 over 3. Minus and minus, it becomes plus, right? So the value of I2 is 95 over 3 plus 4 root 2 over 3, right? Okay, now we can add both the integrals. So therefore I is equal to 2 times, here we have the factor 2, and we have 4 root 2 over 3 plus 95 over 3 plus 4 root 2 over 3, right? So now we have 2, and 4 root 2 over 3, 4 root 2 over 3 is 8 root 2 over 3, and here we have 95 over 3, right? So now we can take 3 common here, so we have 2 over 3, 8 root 2 plus 95, right? So viewers, the value of this integral is 2 over 3 times 8 root 2 plus 95.